Alright, what we're doing today is more on the law of sine, and we're going to be doing application problems, so I know we're all excited to go and do more word problems here in the next section. So, let's look here at some of the examples that we did in class. First one, we want to determine points on the opposite side of a river. So again, all we want to do is to draw the picture. That's the toughest part of any of these problems. They're saying point A and point B are on opposite sides of a river. They want to know in the end the distance between them. To do it, they found a point on the same side as A and called it point C. Well, now guess what? We have a triangle. If you want to get, multicolored pencils or something like that that would help you, I encourage you to do it. Point C, it says, is 1280 away. Angle A is measured to be 41 degrees, and angle C is 46 degrees. So what we want to find is the length between A and B. That's the same as saying side C. We want to find here in blue side C. Well, to do that, we're going to want to use angle C, which is 46 degrees. That's sine of 46 degrees over the side length C. And then the other piece of information we know is we know side little b, 1280. However, we don't know angle B yet. Well, we can figure it out based on triangle sum theorem. We know that angle B is going to have to equal 93 degrees. So this becomes sine of 93 on top. Cross multiply like we've done a million times. C sine of 93 is going to equal 1280 times sine of 46. When you solve, you should end up getting that C equals 922.02 feet. 922 feet. Another example. This one involves something like the Leaning Tower of Pisa. So we're going to have a leaning building, and we're going to have a ladder that's going up to the building. So let's say there's my ladder going up to my Leaning Tower of Pisa type building going on here. Okay? Here is then the ground, which I'll try to make in green. There's our green. It doesn't really give us any point names, but I'll name a triangle anyway to make it easier. We'll call it triangle ABC again, because I'm boring and like making it ABC. And what we know is the ladder is 123 feet tall. We know that the base is 73 feet away. The only other thing that we know is that the tower makes an 84-degree angle of elevation, or angle with the horizontal. So we should be looking with the horizontal in the building. That is your 84 degrees. So what parts do we know? Well, we know side C and we know angle C, so I'm going to use that for sure. Sine of 84 degrees is going to equal, or over 123 should equal. Now what else do we know? Well, we know the ground of 73, so that means we could then find the angle of it. That means that if I know the ground is 73, I can find the angle. That'll be sine of big B. Now keep in mind what we want to try to find in this problem is how far up the ladder hits. We want to know how high this is. So we want to know in the end, we need to know side A. So our answer in the end, we need to find the height, which in this case is side A. But we can't quite get to that yet. So we gotta go one step at a time. First, find angle B. Cross multiply, you should end up getting that sine of B is equal to 0.590 when you do your division. So then the inverse sine of both sides means that B would equal 36.2 degrees. Now, at this point, I should definitely check and see, well, wait a minute. I was given something that is angle side side, or side side angle. Therefore, I should see, is there another triangle possible here? Should I be trying to find one triangle or two? In this case, I would find that the other possible angle, B prime, would be 180 minus 32.2, which would equal, in this case, 143.8 degrees. And 143.8 combined with my original 84 cannot possibly happen. So only one triangle will work in this case, but it's always good to go and double check. So because we now know angle B is 32 degrees, we can then find angle C, which has to be 180 minus those two angles, which means angle A should be 59.8 degrees. Now that we know, I'm sorry, that's not angle C, that should be angle A. I do that quite often. So now we know all three angles, including angle A, which means now I can find side A at the same time. So now I can do sine of 59.8 degrees over side A is going to equal, and I can either use angle B and side B, or I can use my original ones. I'll use the original one just because it's there. Sine of 84 degrees over 123. Cross multiply and solve, and I should get A in the end equals 106.9 feet. The third on your homework I'll leave for for the notes, I'll leave that for exercise for you, but I'll let you know that the final answer in number 3 on that sheet should have been that C equaled 117.6 feet for that. So I'll let you try that one out on your own if you would like. All right. Now, moving on to the two triangle ones that have two possible answers. A plane is observed in the air. So, we're going to have some plane that's flying by. I'm a terrible artist, as you guys all know very well. And we have two people who are looking at this. So here's one person, here's the other person. That's the one possible angle that we're looking at. What it says is the angles of elevation looking up to this plane are, for each, we're going to look at two men. They are 100 feet apart. The angles are, we're going to say 31 and 22. Doesn't matter which one is which, just as long as we have both, 31 and 22. And we want to know how high is the plane if the men are on opposite sides, which we have here, or if they're on the same side. So if they're on the same side, I'll try to draw that picture over here. We'll do that one in green. If they're on the same side, that means I got one guy here, and I have another guy who's this way, both looking up at the plane like so. In this case, something like that. In the end, we want to know how high is the plane. So in the first triangle, we would want to look something like this. We need to go straight down to make a right angle with the ground. Same thing over here, straight down. In this case, we're outside the triangle. But here we're still 100 degrees. The angle of elevation, that means that when we do this, this angle is a lot bigger than this angle right here. I should say this is smaller than this is. The closer I am to being directly under it, the bigger the angle of elevation. So this needs to be my 31. This needs to be my 22. I'll get back to the green triangle on the same sides in a minute. So opposite sides we're doing in green, for opposite sides in blue, and same side in green. We're going to start with the blue triangle, and what can we figure out? Well, if we know the two angles here at the bottom already, that means I can know this angle at the top. Again, let's see if I can name this triangle. We're going to name it here A, B, C. It means I can find an angle C, and in this case, angle C is going to have to be, angle C will have to be 127 degrees. So now if I know angle C is 127 degrees, I can go and make a good proportion here. I can say that sine of 127 over side C 100 over 100 will equal, I should look at sine of, and it really doesn't matter which angle I use, I'm going to say sine of 22 over side A. So I'm going to be finding this side over here. When I do that, I'm going to go and find that A should equal sine 22 times 100 divided by sine of 127. Sine of 127. So when I do that, I should plug that into my calculator and get an answer of, let me check my work right here, and get that side A is going to be equal to, where did it go? 64.49 feet. If I went the other way, if I wanted to find side B first, it really doesn't matter. I'll let you know the answer though. It would have been that B was equal to 46.9. Doesn't matter which one you do, but just so you have that option. So, what I now have is I have a right triangle, which I'm going to do in purple here to try to show you where this is. This right triangle, I'm going to draw it again down here. This right triangle that I have, we want to find this height. We want to find the height of the airplane. I know A is 64.49, and I know that this angle is 31. So now I'm back in the right triangle trig. I have an angle, I have something opposite, and a hypotenuse. So I can say sine of 31 is equal to opposite over hypotenuse, which means it's just equal to h over 64.49. All I do, multiply by 64.49, and that means that my final answer, h, is going to be equal to 24.16 feet. So that is my answer, 26.14 feet. That is my answer for if they are on opposite sides, is that it's 26 feet in the air. Not very high in the air, to say the least. Now, in this triangle over here, the green triangle, for opposite sides, or I'm sorry, for if they're on the same side now. I'm losing my mind. On the same side. Well, let's see. I only know one angle in a triangle, but I can find this second angle right here because it makes a linear pair with the ground, with this 31 angle of elevation. That means this angle right here would need to be 149 degrees. I'll write it in pink, 149 degrees. Because of that, I can then find the angle up here, I'll call it angle C again, that this is 9 degrees. So we'll call this again A, B, and C. What I'll do from here, same thing I did before. I'm going to say that, I'll do it in green again, that sine of 9 degrees over 100, because those are the ones opposite of each other, is going to equal, I want to find, it doesn't matter which, I'm going to find this side right here. I'm going to find side A again. Is going to equal sine of, I need to do 22 degrees because it's across from A, over side A. Do the cross multiplication, I should get in the end A equals 239.47 feet. 239.47 feet. Now, same thing, I'm going to have a second triangle that I can look at. I'm going to make this triangle in red. This right triangle, where in this right triangle, I now know what A is. I'll just draw it separate. I know that the angle is 31 in this triangle, as I can get from here. I know A is 239.47, and I want to know what the height is. So again, I have a right triangle trig with sine. That sine of 31 will equal h over 239.47. Multiply both sides by that 239.47. I get that the height of the plane is 123.3 feet. 123.3 if my computer would behave. So that's when they are on when the people are on the same side of the plane. All right, just so we can look at one more, I will set it up for you. I would suggest you pause the video while I set it up, and that way when you're done, you can check your answers with what I get. All right, so in this case, we're looking at a hill. Again, you don't have to draw the hills and the plains and all that if you don't want to. First one I'll make in blue if you're on opposite sides. The angle of elevation here is 24 degrees. The angle of elevation over here is 17 degrees. So that's looking up to there. And then we're connecting them. And they are 500 feet apart. Again, we want to find what the height is over here. So what we'll do for this triangle is we would find the top angle needs to be 139 degrees to the top of the hill. Again, I'm going to name it A, B, C. I want to say that sine of 139 over 500 is going to equal, I can either say sine of 17 over B if I want to find B, or if I want to find A, it doesn't matter which, I could have said equals sine of 24 over A. I'm just going to say I solve for B. When I do that, I should get B equals 222.8. Now I have a right triangle to look at. Now my right triangle looks something like this, still with 24, 222.8, and I need the height. So that means sine of 24 equals h over 222.8. Multiplied out, h should equal 90.6 feet. So that's for the blue triangle. If I want to do on the same side of the hill, so now I'm going to look like this and like this to the top of the hill. I'm going to make a purple triangle now. going to still call it triangle ABC. What I know is the bigger angle should be the one closer in because I'm closer to 90. 24 degrees there, 17 there. That means that I'm going to have a secondary angle in here of 156 degrees, which means my angle up top, angle C, is going to be 7 degrees. So the same thing, they were 500 feet apart. I need to find H. I'm going to set up in this one, sine of 7 over 500 is going to equal, we want to say, to sine of 17 over A. Again, I'm just going to find side A. I could have said side B, which would have been sine of, I would need to use the big angle in that case, 156. Either way would work just fine. What I'm going to do with these ones, A equals A would equal 500 times sine 17 divided by sine of 7, which should give me 1,199.5. I want to redraw that triangle, which I'll draw in green down here. It should look something like that. There's my height. I need to use the 24 degrees, and I need to use side A, 1199.5. Sine of 24 will equal H over 1199.5, which means that my height in the end should be 487.9 feet. So that's for on the same side, and then here in red will be on the opposite side.